Hi all, let us try to attempt PSPM 2016-2017 section 8A. A 200 cm cube glass cylinder is filled to the brim with mercury at 27 degrees Celsius. Calculate the amount of overflow when the temperature of the system increases to 100 degrees Celsius. The coefficient of linear expansion of the glass and mercury are 4 times 10 to power of negative 6 per Kelvin and 6 times 10 to power of negative 5 per Kelvin respectively. These questions carried 4 marks. According to the questions, a 200 cm cube glass cylinder is filled to the brim with a mercury at 27 degrees Celsius and calculate the amount of overflow when the temperature of the system increases to 100 degrees Celsius. So by using the formula of V equals to V naught plus coefficient of volume expansion times V naught times change in temperature or rise in temperature, and the gamma equals to 3 alpha, and the unit for the alpha is per Kelvin. So we convert the temperature into Kelvin, or you just leave it to degrees Celsius. It's going to give you the same answer. Substitute all the values accordingly into the formula of V equals to V naught in bracket 1 plus gamma times delta T for the glass cylinder, and the volume is 2.0018 times 10 to power negative 4 meter cube. And we're going to do the same process for mercury. You will get 2.0263 times 10 to power of negative 4 meter cube. Therefore, the amount of overflow is the change of volume between mercury and glass cylinder. So the final answer is 2.45 times 10 to power of negative 6 meter cube. Simple like a bubble without giving you any trouble. Let us try to attempt another PSPM questions year 2019 and 2020 for the section 11A and 11B. For 11A, a gold rod is in contact with a silver rod. The gold end and the silver end of the compound rod is at 90 degrees Celsius and 30 degrees Celsius respectively. The silver rod has thermal conductivity 427 watt per meter per Kelvin, length 2.5 cm, and cross-sectional area 7.85 times 10 to power of negative 5 meter square. If 341.3 joule heat flows through the gold rod in 10 seconds, calculate the temperature at the contact surface. It's going to give you 4 marks for section 11A. And for the section B, the area of a metal plate changes from 120 meter square to 120.059 meter square when the temperature increases by 30 degrees Celsius. Calculate the coefficient of linear expansion of the metal. And this is about 2 marks. Here the temperature increases or rise by 30 degrees Celsius. The rate of heat flows dq dt, which is equals to 341.3 joule per 10 second, equals to 34.13 joule per second or 34.13 watt. According to the question, a gold rod is in contact with a silver rod. So we should assume that the rate of heat flows through the gold rod is equals to the rate of heat flows through the silver rod. And the thermal conductivity K for the gold is not equals to the thermal conductivity of the K for the silver. By using the formula of rate of heat flow, which is equals to negative K times cross-sectional area times temperature gradient, and we consider only the silver portion and substitute all the values accordingly into this formula, and finally you will get the temperature at the contact surface is 55.46 degrees Celsius or 328.46 Kelvin. Simple like a bubble without giving you any trouble. And for the section B, by using the formula of change of area equals to beta times A naught times change in temperature or rise in temperature, and it is crystal clear that beta is equals to 2 alpha, and we make it the coefficient of linear expansion is the subject and substitute all the values accordingly into this formula. Finally you will get the coefficient of linear expansion is 8.19 times 10 to power of negative 6 per degree Celsius. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.